So if we would look at a really basic Pygame game, let me see here. Yeah, that's the one. This is the one we're going to use as some of our, all right, let's see here. Gotta fix this really quick. Get rid of my, because I moved the file around, now it wants a different directory. I think that's it for that one. Let's see. There we go. Okay, so this is a very basic game where I'm flying an airplane and I can control its movement. And I have to stay away from these little missiles that come across the screen. So they're randomly generated. The speed of the missiles is randomly generated. And it'll keep going until a missile hits my airplane and then it just exits. It's not a very fun game. It's not a very well thought out game, but it shows you the basics. So all of these things on the screen are sprites, right? The airplane is a sprite. Each missile is a sprite. And the game, each time it updates one of these things, has to keep track of where that thing is, whether it's touching the airplane or not, and all of that stuff is handled by Pygame with just a few lines of code. So when I'm looking at this game, each of these little images is what we call the surface of the sprite. The surface of the sprite, just like the name implies, is what we see. The surface of the sprite is the part of the sprite that we can see. And these are just simple images, very low resolution, very small images that I imported as the surface of the sprite. The sprite really has two parts, the part you can see and the part you can't see. The part you can see is the surface. The part of the sprite that you can't see is called the rectangle. The rectangle represents the part of the sprite that can run into something else. So the rectangle of the sprite in this game is derived from the size of the image. So the image file is maybe like this big, just slightly larger than the airplane. The rectangle, I've told Pygame, is the exact same size as the image. So wherever this image goes, the sprite takes the surface and the rectangle travel together, and there's a little rectangle around each one of these little missiles. When they touch, I've instructed the game to end, to stop playing, but I could just as easily display like a game over, or maybe I have multiple lives where I could take one life away each time, and then if you lose 3 or whatever, the game ends. I define the rules, but I have to tell Pygame what I'm doing. So the sprite, every sprite consists of a surface and a rectangle. A couple other things you need to understand about how this works is when I'm creating a game, there's 2 parts of each screen change. First part is when it's drawn in the computer's memory, and this is called blit. When I blit something to the surface of the screen, or the surface, the rectangle, the surface, the image that I'm doing, and I tell it where, basically I'm saying, put this object at this location on this screen in memory. It's basically, if you think of, did you ever make flip books when you were a kid? So you make a flip book and you take a little notepad. I used to absolutely ruin a whole stack of Post-it notes because they're very convenient size for this. But you draw a little picture, and then on the next page, you draw a slightly different little picture. This is very similar to what we're doing in the game, except as we're flipping the book, we're also drawing the image on the next page. So while I'm showing this image, I'm also blitting the next image behind it, so that when I say screen flip, it flips to the next image, and I see that one, and then I'm drawing the next one already. Because we can't predetermine where everything is going to be inside a game, because it has to respond to the game controls, to the players, to random events that happen. So each time we play the game, we're drawing each screen as we go. And remember, this can happen 30 to 60 times a second. In a really advanced game, it can be over 100 times a second. So there's a lot of computing power associated with that. The third and final sort of concept that you want to understand with Pygame and creating games is called the game loop. And just like we talked about in event-driven programming, this happens as long as the game is running. This game loop is continuing to go. And the game loop in Pygame does all of these things 60 times a second. So the first thing it does is it says, is there any user input? Is the user pressing a key? Are they moving a gamepad? Are they pressing a button? If so, how do we need to update the sprites? Are the missiles needing to fly across the screen? Is there a new missile that I need to draw? Does the player move? So all of the locations of all the sprites are updated. Then, in memory, we're drawing the background. So we're basically blending the background, which in this case is just solid blue, but it could be an image as well. We'll draw the background on the screen. Then on top of that, we're blending the sprites and the objects, anything that goes on top of that background. And then it says which sprites are touching each other, which rectangles are in each other's proximity, and do we do anything about it? If a missile hits another missile, in this game we don't do anything about it. But if a missile hits the airplane, then the game ends. Okay, after the collision check, then the display is flipped. So we're showing the next image. And at this point, the game says, maybe I need to slow down a little bit. Now, this is a weird concept, but today's computers are capable of so much more power than is required by Pygame that we actually have to slow down the clock, because otherwise the game would be over before we could even move, because everything on screen would happen too fast. So we actually have to slow the game down a little bit by putting these little tiny pauses in the game loop. So it's actually going through and pausing so that it doesn't do too many frames per second. And then the final thing is, do we continue the loop? Is the game over, or do we continue it? So when the game actually ends, the game loop ends as well. So it's doing this game loop nonstop until the game is done.